Hello, and as you guys are, filing in here nice and slowly, we'll give it a minute or two before we get started. Want to make sure we get as many people in before we kick this off. And our numbers are looking good. All right, I guess that's long enough. I guess we can get started, right? Yeah.
Sorry to interrupt. Hey, everybody, welcome. I know in past weeks, we have had an issue with folks, once like our presenter starts sharing, they have said, can't see the screen, can't see the screen. So I don't interrupt Matt while he is doing his thing. Can we give any guidance there? I know people have said, log out, log back in, try refreshing. Because we're not all seeing the issue, but I just, you guys can definitely, if you can't see, pop a message in, but we've seen this happening. Any words of wisdom, Matt or Robert?
I haven't been able to recreate it. I kicked off a GoToWebinar and here at the house, and I've been running two different machines, both Mac and Windows, and I haven't noticed any issues with that. So I don't know if it's necessarily GoToWebinar or something local on the security. If you have corporate security that's preventing something like that, that might be happening. But we've been investigating this issue, trying to figure out what could be necessarily the cause of it. And so we don't know just yet. We are looking at other platforms such as Crowdcast to switch over and move over to another platform. And there, we haven't seen this issue yet, but if we do, we obviously are going to put this back to them. But we'll reach out to GoToWebinar for the time being because it is still our platform of choice, and we'll see if we can get some assistance in troubleshooting this for our community members. Awesome. Well, I guess I can get started. Hello and welcome. My name is Robert Sertia, and I am a technical evangelist here at SUSE. And your part of summer is open. Now, we understand it's not summer everywhere, and we also understand it's not open everywhere. But this summer, we wanted to start showcasing some of our open source projects that are on their way to becoming products. And this week is week 4 of our 7-week series around Hypper. And I am glad that he's back. I have a special guest today. It's Matt Farina. He's our software architect here at SUSE, originally from Rancher Labs. He sits on the board of a nonprofit, Joy Creativity, a current maintainer of Helm and Artifact Hub, and an emeritus chair of Kubernetes SIG apps and architectures. Matt, welcome. Thank you.
Hi, thanks for having me.
Thanks for coming back. So, Matt, we've had this conversation before. You've had an incident with Raccoons actually breaking into your house, and it's a funny story because, like, you were telling it, and I'm drinking coffee, and coffee came out of my nose. It was pretty funny when you were like the way you did this. So, you want to tell us, what happened?
Sure. So at the time, I work remotely, and I had to go to an office in Seattle for a trip. So I went to the office, and I had a Friday afternoon meeting. And so I worked through that meeting, but I wanted to be home, get back with my family. So I decided to take a red eye back on a Friday night. So I take the red eye back. I get home about 6 a.m. local time. About 7 o'clock in the morning, after just an hour of sleep, my kids come rolling into my room and saying, "Dad, there are raccoons in the house." Oh, first of all, that woke me up very quickly. And I'm like, "What are you talking about? This can't be true." They're like, "No, Dad, really, there are raccoons in the house." So I get up and I go look, and sure enough, there's a couple of raccoons eating out of my dog's dish. And the funny thing is, so I've got a dog who at the time barked at everything. I have people who walk up and down the street doing regular, every day they walk. Every day, the dog barks at them. Never learns it's the same people, barks at everything. Never noticed that there were 2 raccoons who'd come into my house. Now, we were lucky. This is by a side door in my house, and it's a little hallway, and I had a kid gate there at the time, so I closed the kid gate. I was able to walk around the outside of the house, open the door, and the raccoons left. But they'd actually pen tested my house. Is a good way to think about it. They pen tested it. Literally, they broke into my house. Under my deck at home, there was this spot you couldn't see. And I bought the house and I'd never seen it. I'd lived in it 6-7 years at the time. And there was a spot. And the last owner had not sealed it. They just put up insulation there. So on the inside of the house, you thought, okay, this is part of an unfinished basement area and there's just insulation there. On the outside, there was no wood, no concrete, no nothing, just the other side of insulation. And the raccoons pen tested my house by pushing right through, trashing my basement, and coming upstairs and deciding to eat my dog's food. And so they pen tested my house. And after an hour's sleep, I got to deal with this.
And you know, as the dog is the security system at home, it just didn't even notice that there was an intruder, actually 2 intruders sitting there just eating his food and just every day. Wow.
Actually,
Awesome.
just walked back and forth past that hallway repeatedly, never noticed a thing. Didn't even have to deal with it barking or getting upset with the gate closed. Never noticed ever at all.
It's a great analogy for a pen test right there, and the security that you had just kind of failed right there, just walking back and forth. So, well, we're here to talk about Hypper, and Hypper is a project that's obviously near and dear to you, but we have a couple slides that will explain that better. So let me bring these up, and then you can kind of explain to us Hypper.
Sure.
All right. So, first slide.
So Hypper is a package manager for Kubernetes. And so that immediately draws comparisons to Helm. You know, you have to ask questions like, why did you create another package manager? There's already Helm. How does this compare to Helm? Because Helm is, you know, when Helm started off and there was the Kubernetes space, there was more than one package manager back then. There was KPM and there were some others. And Helm kind of showed up as the one that succeeded and maintained long-term. And so why create another package manager now? And the reality is, if you look at the first bullet on each side, Helm targets your application operators, distributors, people like that, right? So you as a Helm user are going to take something like WordPress or MySQL or Postgres or something like that and install it into a namespace. And you might have multi-tenant users in a cluster who don't even know about each other. In fact, if you're dealing with trying to use the scaling and try to get lots of resources out of your clusters, you may have multi-tenancy. And Helm is designed with that in mind. It's designed with this idea of we don't know everything running in the cluster. You don't have permission to everything running in that cluster, but you can package manage and install applications, run them, and all of that. Hypper takes a different approach. Helm does not target cluster administrators or cluster operators. It targets those application operators and distributors. Cluster admin can see everything in a cluster. They typically deal with cluster-wide services, Prometheus, Fleet, maybe your logging setup, maybe if you've installed some operators, you can have a SaaS in your cluster, like Postgres as a service, maybe using the Crunchy Data operator, something like that, right? They see the world, and a lot of times their stuff can be interdependent on each other. If I install WordPress 10 times in a cluster, you're probably each time going to use a different MySQL instance of that, and different multi-tenant users are going to have different databases in different areas. If you are, wanting Prometheus installed, or maybe a cluster-wide service that depends on Prometheus installed, you probably want to use that same Prometheus every time and have it be a cluster-wide service. And so the assumptions were different. And so Hypper targets that cluster admin, that cluster operator, in trying to make it easier for them to do package management at that cluster-wide scope, while Helm focuses on that application operator, application distributor, with that multi-tenant use case, if that makes sense.
It does. So this is one of the best. Like I remember asking you, like I don't get the use case, and I think when you explain it to me that way, it just takes it up a level. And I've never worked at that level. I've always tried to keep close to the developers, and it made sense as soon as you laid that out. It's targeting cluster wide and beyond that. So it clicked for me and why it's important to have Hypper.
And the thing I'll say is Hypper is built on top of Helm. So it's a regular old Helm chart with some extra metadata that Hypper is then able to operate on. So all that same stuff that works with Helm works with Hypper. It's just got a little bit more that's enabled by metadata. And we'll walk through that in a little bit.
Awesome. You ready for your next slide?
I am. In fact, in the next slide, I talk about how it works. And so this is kind of a look at, on the one side, you've got the Hypper client. which uses the Hypper SDK, because one of the things about this is we wanted to make it just like Helm. You can build stuff on top of Helm. You can build other applications on top of Hypper. You don't just have to use the client CLI. So you've got a Hypper client that uses the Hypper SDK, that uses the Helm SDK for repos, charts, provenance, which is a security feature, for the Kubernetes clients, to deal with templates and rendering templates, to deal with storing releases in cluster. All of this stuff is actually Helm, and it's part of the Helm SDK. And Hypper just then uses those public APIs and the public SDK, all written in Go, and so Hypper's written in Go, to do this stuff. So that same stuff you get in Helm, those same features, if you want to know if I installed something with Hypper, can I deal with it with Helm later? You'll actually see that in a little bit. The answer is yes, because under the hood, we're actually having Helm do all the work. It's just business logic built on top of that, that's wrapped in an SDK in a client. And then it interacts with Kubernetes the exact same way Helm does, because it's literally using the same code paths, because the Helm client uses the Helm SDK.
Awesome.
If that makes sense. And the next slide will actually get a little bit more into that. So if you could go to the next slide, you will see, so if we take Hypper and just look at it as a binary, when it installs things the same way Hypper would. So it installs a service with a Helm record, and it actually uses the real Helm regular unmodified release record to do stuff. And so Helm can go look at that record and see something that's installed the same way Hypper can, because it's all really Helm under the hood, all Helm package management. It's just that extra business logic on top. And so it stores things and interacts with the cluster in the same way. So if you ever wanted to switch off of Hypper back to Helm, or upgrade something with Helm instead of Hypper and then come back to Hypper, it all works.
Wow.
It all works. So my next slide here actually talks about one of the first of the two primary use cases I'm going to talk about with Hypper, and I touched on it before. Let's say you have service A and service B you want to install into a cluster, and you both want them to use the shared Prometheus in this example, or the shared other service. If you're doing Helm and its normal dependencies, it'll each install its own Prometheus. The other way you can do that with Helm is you can install Prometheus, and then when you install service A and service B, you can configure them to point to that shared Prometheus. That's a lot of extra configuration that you need to do. You can't do a lot of the automated discovery because you don't know where things are in a cluster. When you deal with that cluster administration, and if you're dealing with apt or Zypper or any of those things, you're usually dealing with like operating system wide. And in this case, you can think of a Kubernetes cluster as an operating system. Kubernetes is kind of like your cluster-wide operating system in this case. You know, when you deal with those other systems, they know where other things are at when you get them out of the same repository to know how to talk to each other. Some of them are smart about being able to switch between repositories, and you can have forks of certain services, but they all know how to find the other system-wide services. And so that becomes like a shared system-wide service. Hypper does the same. So in this case, service A and service B, right? If you install service A and Prometheus isn't installed, it'll go ahead and install it. And service B comes along and says, I need Prometheus. It knows where to look for it. And if it's there, it doesn't do anything. It can use it. And if it's not there, it then knows to install it, because they can detect the presence of that other system-wide service and then use it or install it if it's missing, which is more akin to your dependency management when you're thinking of cluster-wide and cluster admin. And so shared services is a big example for how this works.
Awesome.
So if you go to the next slide here, it'll get into that other case. And this is CRDs, all right? Now, my preamble on CRDs is CRDs are, well, complicated, right? And I grabbed the first quote here is something I grabbed from Brendan Burns. He is one of the co-creators of Kubernetes. He worked on the thing that was the precursor to CRDs, which CRDs let you extend the Kubernetes API, right? And so this is a quote he wrote from kind of a write-up after the fact when we're looking back on it. You know, and it's the primary motivation for custom resources is to provide an extension mechanism. And the thing that he equates it to is loadable kernel modules, right? So they're not user runtime things. They're equivalent to kernel modules that you would do. And so they're system-wide, right? If somebody updates a kernel module and you've got, you know, 3 tenants who can't see each other, it updates it for everybody. And it changes everything for Well, everybody across your whole cluster. If you remove a CRD, all of the custom resources are removed for everybody in your cluster. So if somebody's mucking around and happens to remove a CRD, and there's another tenant in there, all their custom resources for that are deleted and everything's gone. So there's a lot about it. In fact, in Helm, we wrote the Helm improvement proposal, HIP 11, actually talks about Helm's philosophy about this, if anybody wants to go look, but it talks about the ins and outs and all of that stuff. And so they really are kernel extensions, which is more of an operator thing than an end user thing. But one of the things Helm does is when we say if you're going to manage CRDs, this is right from the Helm docs here, the second quote, it's called method 2, separate charts. You have a chart that encapsulates your CRDs, then you have another chart that encapsulates your application. Now you need to install them as 2 separate charts then, because if you make your CRD separate chart a normal Helm dependency, let's say you've got an operator and a CRDs for it, and you uninstall the operator, the CRDs are uninstalled. Now let's say a common problem if something's acting up is you uninstall it and reinstall it, right? People have been doing that for ages. Well, if you do that and you got that tight dependency, you uninstall the operator chart, it automatically uninstalls your CRDs if you put things in the templates directory, and all your custom resources are deleted and everybody's screwed. But if they're 2 separate charts and they're managed separately, then you uninstall the operator and reinstall it, nothing happened to your CRDs because that other chart wasn't touched. And that's one of the things that Hypper will let you do with its dependencies is you can actually say install that CRD chart, but once it's installed, it's a separate thing. Don't go uninstall it. So I can uninstall and reinstall as many times as I want the operator without ever mucking with those CRDs that were installed through the templates directory or anything. It gives you a little bit more control in that space while still having the dependencies. And these 2 things all together as use cases were actually born out of Rancher, the core Rancher project and product that was part of Rancher that came into SUSE, that core main project. These features that I'm talking about here are actually in Rancher itself today. And what really happened was we said we got Helm and we built all this business logic on top of it, and the place it's in Rancher is not ideal, and we want to use it in other places, and we know other people will want to use it. So these kinds of situations, we're going to break into a whole separate system, a separate application. We ended up naming it Hypper, which is actually named after Zypper, and Zypper is the package manager for SUSE Linux, right? So that's where the naming comes from. And so we took that business logic out, took lessons learned from it, and rebuilt it in Hypper. And so these things have been stuff we've been doing inside of Rancher for a while, and now we're making them more general purpose and trying to apply some of our lessons learned.
So you don't necessarily need Rancher to use Hypper. Is that what you're saying?
Yeah, you don't need Rancher to use Hypper. Anybody can use it for anything. And it's our way of breaking that out and making it more general purpose.
Awesome, awesome. You ready to do a demo?
I guess so.
Okay.
You want to give me control here and I'll share my screen?
I do. Let me do that real quick. There you go.
All right, can you see my screen?
Yes, sir.
All right. So go ahead and minimize this. So I have a Kubernetes cluster running. It's running locally. It's Rancher desktop. And what I have is I have a normal repo. So I have Hypper. All right. And Hypper, like Helm, has very similar commands to Helm. Hypper, you can actually see it's got a bunch of commands that should look familiar if you're a Helm user. Install, lint, list, which lists your releases, pull, repo, search. It doesn't have everything that Helm has because it is something that will, right now, it works complementary to Helm. And so you can use the 2 side by side, but it does share its information separately. So if I list my repos, I'll see one repo here with Hypper. But if I look at my Helm repos, I have more than one repo for Helm in here because the metadata and configuration are stored separately from each other, so they don't step on each other's caches or anything like that, but you can use them the same. In this case, I have a repo here, and it's up on GitHub. I've named it demo for demo purposes, and anybody can go look at it. That's where you can find the repository. And you'll see I've got it in both places with the same name. So when I jump back and forth and I use the names, that's kind of what's going on. All right, and I can look at what's running in a cluster already. So if I do ls is short for list. If I do that, I'll see there's nothing in my default namespace, but if I look at them all, this is the same command you can do with Helm, you'll see I've got a number of things running. Since I'm running K3s, I have traffic installed, and beforehand I was mucking around and I have Rancher logging installed, and it is installed in the normal place, and I did that with Hypper. Now, if I want to look at what's going on, I can do the same thing with Helm, and you'll see the same results because it's pulling the same information. And each of these things is something that was installed, together. So to look at this, let's go look at a chart. And so let's go look at a chart and see what's inside one of these charts. And so I'm going to use the Helm show command, Helm show chart. And this is a command that can look at something in a Helm repository. So I have a Helm repository, and it's got a bunch of charts in it. And let me show you one of the charts. And this is literally my demo chart. And what I can do, we'll give it a little color here. And you can look at this chart, and you'll see from its chart YAML file, it's a standard chart. It's got the API version, an app version. It's a dummy Helm chart for Kubernetes. Its name is demo. It's just a very, very basic thing. But then you see annotations here. And annotations are the bread and butter of what Hypper is able to do. Instead of storing this in GitOps or Git somewhere, all of the dependency relationships are stored within charts themselves, so you know what's going on. And so in this case, we have the Hypper _IO shared dependencies. And there's actually another one called optional dependencies, and Hypper will prompt you for the optional ones, but the shared dependencies are the required ones. And so here I have a hard requirement on demo A and demo B in this repository. This same layout it's the same layout you get with a normal Helm dependency, but it's in a different place. And the way we did it with the shared dependencies is you'll see this mark here. That means what's underneath is a blob of text. And we just parse that as YAML in order to get the information out, because Helm annotations are key value pairs. And so this is the value when we parse it as YAML. So if I go to install it, you'll notice a difference here. With Helm, I normally have to specify the name. In this case, you can specify the name, but if you do it with Hypper, Hypper is going to read it, and it'll pull the name from the release name here, and it'll pull the namespace to install it from here as well, along with its dependencies. So I'll go ahead and run it. This is very lightweight to run, and you'll see that it's installing demo, and it shows me the tree here. It shows me that demo depends on demo A and B, which you see here. But B, which I didn't show you, also depends on demo C. And so if I come look at demo C, you'll see demo B depended on demo C. If I go look at demo B, it also depended on demo C in the same repository. So Hypper shows you a picture of what needs to be installed, and then it goes ahead and installs it, right? Now, we'll go look at everything installed, and you'll see demo A, B, C, and demo. You'll see they're each installed to the namespace that was specified in their annotations, as well as the release name specified in the annotations. Now, if you don't specify a namespace or a release name, you go to install just a regular Helm chart, it'll install it, it'll use its name as its default release name, and it'll use the current namespace as the one to install it into. So it does have fallbacks to it. Now let's say we'll do, we'll uninstall demo, and we'll uninstall it because it's in the demo IT namespace. This is the same. Was it the name? Oh, you know what? I missed the name and the namespace. So there we go. We'll uninstall it. And if we go look at it, you'll see it's not installed. So let's go install it again. We go look at this. What's going to happen is it's going to look at it. It saw that all the dependencies were already there, so it left them alone, right? And so it's able to look at your dependencies and see what needs to be installed and what doesn't. And so that's a really useful thing. Now let's get into a little bit more. So we can go look at this. Now, this is a silly example, and you'll see I actually have Rancher logging installed. That's the real Rancher logging. I pulled it out of Rancher's system for charts that you'd install into a Rancher cluster, and I pulled it into ours and updated our annotations because they're a little differently. But I do have, you'll see, because Hypper doesn't have the show command, and the show command is a command in Helm that'll let you see what's going on. So I'll do Helm show. Oh, that's why. So you'll see I have service A, and I want to show you service A. And bat is a command that's like cat, but it can do coloring and line numbers. So that's why I use it. You'll see I have service A, and this is another dummy service, and it depends on both logging and monitoring. And you'll see Rancher monitoring is in that repo. And so if instead I do Rancher monitoring, we'll show what that has. If I look at Rancher monitoring, it's going to show me that Rancher monitoring depends on the Rancher monitoring CRD, that case that I talked about before. And you'll see I also had the logging, but that's already installed. So if I go to install that, it's going to find out what's missing, show me what needs to be installed, and now it's installing it. And here, because the cluster I'm in, and I'm using a new enough version of Helm, it's actually warning me about some of the CRDs that are being installed and some of the things that are going on. So it installed the Rancher monitoring, and now it's going and creating things. And it's giving me warnings about outdated and deprecated things in the chart, which Helm does now. And it's in the process of installing the Rancher setup, and I've got an example service that depends on both of them. And so it lets me do that kind of tree thing to install things. And so right now it's installing the Rancher monitoring into that namespace. And as soon as it's done, it'll go ahead and install my example service. Now, this is something that takes a minute for it to come up, and it gives me lots of warnings about all the resources created, because unfortunately this chart is using older versions of things. Kubernetes, as of late, has removed a lot of its beta things and alpha things, and we're just using the GA ones now. And so you'll see it installed it, and it installed it. So, and so if I do, gotta throw that A in there, it'll show me everything's installed. So monitoring, logging, my service, they're all installed and everything's there. And so that's kind of the gist of what it lets you do, is those extra things that you can't do with Helm to really help a cluster administrator do some of their stuff.
So when we look at this, it's not necessarily competing with Helm. It's kind of, Helm on steroids to fit another higher level user's need within the cluster itself. So it's kind of Helm, but a little beyond what Helm can just do.
Yes, and there's kind of a reason for that. And I'm kind of come over to the Helm community site. We have this thing called user profiles or roles. And in Helm, if you go look at the profiles, which are really roles, you'll see a priority order to what Helm does its development for. And you'll see the application operator, that person who wants to run something, is your top one. The application distributor, that person who packages up a chart and then distributes it for people to install and run, is the next one. And as you go down, you'll see the app developer, supporting tool developer, which is what Hypper is. Hypper itself is a supporting tool. The Helm developer, that person who works on Helm. This is kind of our priority order here. And what is not in scope is that cluster operator. Now, I tend to call it a cluster administrator now, because the term cluster operator or operator is overloaded with those software operators that people talk about. But it's that person who does those roles is actually not in scope for Helm. And so the idea with Hypper was to build a tool on top of Helm package management, because there's so many resources for that, to give us the ability to target, this role, this profile, and be in scope for this person.
Wow. And contributors for this, it's you and a small team here at SUSE that are here, 2 or 3 of you guys doing a fantastic job with this. In the community, do we have any contributors yet, or is that? still open?
We really don't. We're just now really starting to get out and show it off. This is one of those things where we've been working on it for a little while, dealing with some of the ins and outs, complexities, things like that. For example, it did take us a little while to figure out how we were going to figure out the whole dependency trees, looking at what's in repositories and what's running in the cluster, and to deal with the different versions, because you saw version information around dependencies. We want to make sure that that's there or give people the appropriate errors. And so it took us a little while to get the SAT solver in and working with everything. And so we're just now starting to take out this full feature set for people to look at. And so we hope it's useful and that people will want to come contribute, whether it's just filing an issue or asking information to come get involved.
So what current features are you guys working on? I know last week, I believe you guys had the 0.3 and the 0.3.1 release. Is that correct?
Yes, it was absolutely wonderful. We launched a 0.3 release, and then I started creating the demos for this, trying to put it together, and I ran into bugs. And so the 0.3.1 release was to address those bugs in trying to figure this out and dealing with some of the cases here. And so, yeah, we just released that. That was the first release with the full SAT solver and everything. And so our next go at it is to try to fix up any bugs anybody would encounter, discover any issues, and then start dealing with more stuff around this. So some of the features we would want were, you see the dependency tree when you're installing something. It would be great to see that dependency tree when you're not installing something, just to get information, and to see which ones are installed in the cluster versus which ones need to be installed. To get that separate information so you know what's running, what's going on, that information would be useful. So we want to build out the next things we're talking about is building out stuff to help enable that operator to have some better insight into what's being installed, what's going on, and what's there.
Awesome.
Some of that you can already do. So if you look, there is a shared dependencies. And so if I do, this is how it works. Nope. All right, so it's shared deps. And this is where I always get it wrong. It's shared deps. So it's having trouble. All right. And I'm obviously fat fingering this command, shared dep. Let me come and do unless we broke it. So it's not. Yeah, these live demos, right?
Demo gods were not on our side. So I had an opportunity to go through the challenge. You guys actually, and for our community members, I normally get the opportunity to write up our challenges, but as Matt's doing this, and he actually had the challenge already done. So I was going through and I was playing around with how these Helm charts were, built. I don't want to say goofing off, but I was just playing with it. And because, excuse me, there is a kind of a blob text store and those annotations. Is there any idea or any thought to be putting behind some type of validator in there to make sure that YAML in there is valid? Because you can't validate it because it's blob, but when it gets to Hypper, it could break. So is there any thought about, putting together some level of validation?
Yeah, so we have Hypper lint, and that's what we tried to do. So you've got Helm lint, but we've got some of this additional stuff. So
Okay.
if I go point this at a directory, and we'll go point it at the directory for the demo chart here. This is where I just happen to have it, and I point it there. It'll go ahead and lint that chart. And so in this case, it's an entirely valid chart, and it can tell you those things. But if something were messed up or malformed or couldn't read something, it'll give you a thing. And in this case, it tells you about optional dependencies, which are the ones that have that same thing. So if we went to, we'll go to install an optional one just to show you what that looks like. So if we go to install one with optional dependencies, demo opt has an optional dependency on demo C. So we'll go ahead and say yes. And there are flags to say yes to all, or none to all, that you could pass in. And it got an error. All right, so live bugs. I'm not sure whether it's a problem with that chart, which I haven't tested in a while, or not, but there does seem to be an issue installing it. And this is one of those rare times where I'll have to go trace it because it doesn't give me a nice message. So this is one of those things where I obviously didn't try this, and I was just going to throw it offhand, and somehow I've broken something, probably in my own setup. But that's what's going on. So it does have the ability to do optional dependencies as well, and we do give the ability to lint charts.
Awesome. Yeah, when it comes to YAML, anything to validate my YAML to make me feel better about what I wrote. It's either me or a square at the top of my monitor going like, is it in the right? Is it got enough spaces over? I didn't say tabs, I said spaces. So awesome. Well, I think we can turn it over for questions from the community. Let's see if I can pop over questions here. CK, do we have any?
Hello, sorry guys, trying to unmute. Yep, well, just a couple. Motion, sorry if I'm mispronouncing that, was asking for some use cases to kind of wrap their head around this a little bit.
Yeah, and so I think the use case is you're dealing with the cluster-wide scope, and me as a cluster operator, I want to install, say, an operator for a SaaS in my cluster, right? Like Postgres as a service or something like that. I'll come back to that one. And I want it to use, each time I install one of these, I want it to use the same other set of things like Prometheus or my logging setup. And I don't want to have to install or, I want them to know about each other's locations. And so I can just install it and have the other things there in their known locations. And I think that's a primary use case here, is that cluster operator case. And I want to do those kinds of things. And so as a distributor, right? So like as Rancher as a company, I might have a Helm repository with a bunch of charts designed to work together that can then point and direct to each other. And so I can go deal with that kind of thing and just have them all connected to each other. And that's one of those things that Rancher did. We have this chart catalog that we install that has fleet, and it's got Rancher monitoring and Rancher logging that you can install in clusters. And as things depend on those, we always want the same instances. And so we're able to detect those and then say, oh, it's already installed, I don't need to install it, and just use the one that's there. It's that kind of use case.
Cool. Motion also wanted to know, is this production ready? I mean, you said it's part of Rancher, so I might have missed that, but just can you?
Well, it's not baked into Rancher yet. It's born out of Rancher's ideas. Okay. Is it production ready? I would say probably not. We don't know of anybody using it in production yet. And since we just released the SAT solver and Rancher itself isn't using it yet, we're not at that phase. It's probably not production ready. The nice thing about it is that if you do want to take it for a spin in your environment, you can always just switch back to Helm, because everything is installed as its own Helm chart and own Helm release. So if you install something with Hypper and you're like, oh, I wish I could just do this with Helm instead, you instantly can, because all of the Helm commands work against it, and it was installed as just a normal thing through Helm. It's just Hypper knows that business logic on top of it. And so if I want to switch back between Helm and Hypper, you can. Or abandon Hypper and just go with Helm going forward, you can.
So I think that answers the question one of our community members had. Alok was asking, can I use Hypper to install Helm charts as well? So I think that answers that one.
Yeah.
All right.
Yeah, and then I think you touched on this a little bit too from Brandon, who said Helm charts are represented in the Rancher GUI and the marketplace section. Any plans to add Hypper repos charts into that GUI for people logged in on an admin account?
We have talked about doing it that way, and actually maybe replacing what Rancher has with Hypper. It's going to take a little bit more development on Hypper and some time with Rancher. In fact, if we go look at the Rancher charts repository, so Rancher charts are stored in the charts repository, go figure. And if we go look at something like the 2.5 charts, we'll come in here and we'll go look at fleet, right? So we'll just look at the fleet chart and the latest version of it. And if you come to the chart YAML, you'll see it's a little bit different, but we actually say, here's the namespace to install it to. Here's the release name to install it to. When it comes to dependencies, they're managed a little bit differently. And you'll see provides group version kind, or there's a way to install group version kind. And so it depends on, what does it need to consume? What does it need to have? And so we've got some other annotations here. The problem that we found with this is with CRDs, let's say you got V1 Alpha 1 and you go tweak that CRD. Maybe you added because you can change a CRD at a particular CRD version. Maybe you added another optional field. Well, how do you know if it's the version of the CRD before or after you added the optional field if the version as far as Kubernetes is concerned is the exact same? This is a real world problem because a lot of people who deal with CRDs will add optional fields in after the fact and be like, well, it was optional, it's okay because I didn't, break the API version in some backwards incompatible way because they're optional. And so you can alter CRDs at a version on the fly. But sometimes you need to know, is it the newer version or the older version? Because you don't want to overwrite the newer version with the older version. You'd want to stop that. Kubernetes doesn't provide a way to have that granular of a versioning. But if you wrap the CRDs in a Helm chart, Helm then provides you that way with its version numbers to have that granular number. And so that's why Hypper doesn't follow this provides and consumes. Instead, it wraps it in a chart so you can tie it to the charts version so you can know, is it the newest? Is the other one, oh, it's older, we shouldn't overwrite the newer with the older. That's the way we wrapped it to have that more granular versioning. But otherwise, this is based out of what's in here. In fact, if I took this chart right here as it is, it won't do the dependencies, but it'll use the namespace and the release name information out of here, even though it's a different annotation.
Mm-hmm. So one of our community members, George, asked if Hypper can pull charts as well. Is that a feature in there, or is that something that Helm would have to do?
Hypper can pull charts. So what you'll see is the Hypper commands. There is the pull command for charts. And so you can do that, and it does upgrade, uninstall, install, and list. So yes, it can pull charts. It can work with OCI repositories as well. So if you've got them or OCI registries, so you can have them in a Helm repository, a traditional way, or you can have them in the newer experimental OCI registry as well.
Awesome. All right, this is from Mark. And Mark goes, how do you see Hypper used when installing new clusters that must follow the same pattern as my other clusters?
That's a good question. So what I would, the ideal case would be you've got a Helm repository that has your charts in it you normally want to repeatedly install, and you've got the metadata so that way you can point things to each other within that repository. It's a well-formed structured repository with the annotations so things know where the other ones are within that repository. Then in every cluster you use Helm install, we'll say Helm install, and we'll say Prometheus in. Every time you do that, whether it's a local development environment, a production, one of 20 production environments, it'll all be installed into the same location in each cluster. And so that's the way you'd have a well-formed repository, and it could be for your company, or it could be one company or organization providing it for others to use. Every time you use that repository, things know about each other, and so it'll be installed in the same way out of that repository.
Awesome. So Simon asked a question, is Hypper included in Harvester? And I don't think so. I just got done doing the home lab, and I didn't see anything in there tying it together.
No, Hypper is earlier on, and we're still working on it, so it's not at a point where it's included in other things yet. I mean, just last week we released with the SAT solving, which was a big step to be able to do the full dependency trees that everybody needed first. And so while we create things, here at SUSE that to fill the need, we're not prematurely forcing them into other things. We want to make them really work, and then others can pick them up and integrate them together as it makes sense and as it's ready. And so we're not pushing it. And just last week is when we got the SAT solving finally in. It had been working and testing and all that, but it was finally released. And so now others can start to look at it. They may find some issues with it we need to fix first, and we can start the discussion on, are there any blockers for them using it at that point, and can we then is it useful to integrate it? But that's kind of the approach we take. We're not trying to force it in anywhere yet.
Awesome, awesome. Real quick, next 3 features that you, 1 or 2 features maybe that you guys are looking to hopefully get done in the next major release for there? Do we get a little community sneak peek of what you're thinking about what's coming next for Hypper?
What I think of as coming next is probably some of the other metadata information. So we want to fix any bugs right now, which I think is real important, because if anybody encounters a bug or an issue, that's going to be our top priority. Trying to solve those things and unblock people from being able to use it. Beyond doing that, I think the big next step is going to be the visualization and understanding. Like I said, right now it doesn't show you just the tree without installing, right? I'd like to be able to just see that tree and see what's already installed versus what needs to be installed. Getting some of that information so you can have some more situational awareness, I think that would be useful as well.
Awesome, awesome. Well, as we're wrapping up, I got a slide I kind of want to show to, get people here in the community involved. So.
Yep. So how do can you just take back control?
I do. I just like to let you know I'm doing that.
No, thank you. That's good.
All right, guys, you guys see my screen here. Ways you can get involved. Obviously, use Hypper, provide feedback. I always recommend going onto our GitHub site. You can get there by hypper.io, select GitHub in the top right-hand corner, give us a star. That's one of the best things you could do. Let us know that you're using it. Let us know that you like it. Logging bugs is always that's the biggest one, right? You come through an issue, log that through GitHub. That is, barring on what they're trying to, flush out right now. You can join us through community at community.suse.com. We have a Slack channel, and we have one that's dedicated to Hypper. If you've not joined, you can follow us. Well, you should be following us on Twitter under ranchers_labs. You can follow myself or Matt Farina at Twitter as well. Matt, any parting words for our community members?
Sure. If you like Hypper, please head on over to GitHub and give us a star. If you have any issues or questions or problems, or there's something you would like to see, please just come file an issue. If you're the kind of person who likes to just jump into code, we'd be happy to have pull requests. Our goal really is to be useful. And so if there's any way that you see that would be useful to you or more useful or any of that kind of thing, we're interested. So please come chat with us.
Awesome. So real quick, we still have our harvester sticker giveaway. So if you go to community.suse.com, post a picture of you installed a version of the latest version of Harvester on a home lab, we'll send you a sticker. So you can do that. You can find that through community. I think it's actually one of my featured posts. And next week, we'll be talking to the gentleman over there with Kubernetes, and I'm excited about what this one is. It's, I believe, policy as code. So more to come on that. The challenges will be released later today, and they'll be posted on community.suse.com. I want to thank everyone for your time. Matt, once again, love talking to you. Thank you again for coming.
Yeah, thanks for having me. This is delightful. And I look forward to the Kubernetes one next week too. That's one of my more favorite projects. So
are you going to be
I'm
joining
really
us?
excited about that one. I might be joining you as somebody just quietly listening, because I am interested in Kubernetes.
Awesome. All right. Thanks, everybody.
And hey, don't forget office hours on Thursday.
Always forget
Right,
office
Robert?
hours. Yep, office hours
Did you
will
say
be.
that? I might have zoned out.
I might have missed that, but actually office hours, thank you, CK. Office hours will be this Thursday, 1 p.m. Eastern time, and we'll be here to review anything, questions you might have around Hypper. We have a challenge that's being posted later today, and if you have questions about that, feel free to come to office hours and we'll chat about it.
Thanks, everybody.
Thanks,
Matt.
Thanks for coming.